However well we get to know the world, it will always contain a day and a night side. Yellow and orange hues bear the essence of light, Goethe says. An immediate warmth seems to billow towards us. Blue and violet hues, however, bear the essence of darkness. Like the high blue sky and the distant blue mountains, a blue surface seems to recede from us. When we look at the world, we see colors. We are used to thinking that these colors have something to do with the light. All cats look the same in the dark, we say. If the light disappears, the colors disappear. But if the darkness disappears, the colors disappear too. It's the light and the darkness together that create colors and render the world recognizable. In physics, colors can be measured, but colors possess other qualities and properties which cannot be measured, but which we sense immediately. When the sun rises in the east, we may have the good fortune to observe a very special phenomenon. For a moment, the orange-red light of the sun plays directly upon the cliff, and our shadows appear to be greenish-blue. These shadows are actually grey. Our eyes form the greenish-blue as a counter to the powerful orangish-red light. This simpler setup helps to show what really happens. We illuminate a cone, from the left at first with white light, then from the right with white light. There is now a grey shadow on each side of the cone. If we add a green filter to the left-hand lamp, the whole setup is bathed in green light, except for the part that is in the shade of the cone. This time, when we switch on the light on the right, which is still white, our vision creates a magenta shade where there is room for it, namely in the grey shadow. If we zoom in until we can't see the surroundings anymore, but only the shadow itself, it stops looking magenta and turns grey again. If we view the shadow in isolation, it is grey, but when we see it in the context of which it is part, our vision invokes a magenta shade. Magenta is green's complementary colour. The German poet and scientist Johann Wolfgang von Goethe noticed the coloured shadows and decided to investigate the nature of colour. Goethe is most famous for his poetry, but he also spent 40 years drawing up a theory of colours, and apart from Faust, he regarded it as his most important work. The phenomenon of coloured shadows led Goethe to the view that colours are part of our vision and are therefore a sensory perception first and foremost. He studied the eye with great interest and based his entire theory on man as an observer. About vision, he said, "It will always strive for totality and unity, as we see from the coloured shadows. If the cone is lit from the left by violet light, we create the complementary color yellow by ourselves. Cyan blue light creates the complementary color red. When we are subjected to an outer, uniform color influence, we create balance and harmony by forming an inner, complementary color. Colored shadows cannot be seen on their own, but only in the context in which they appear. They have no wavelength and therefore cannot be measured. So according to the scientists, they do not exist and are dubbed an optical illusion. Nevertheless, we see them. Goethe investigated colors wherever he saw them. He tried to chart their qualities and essence, when and under which conditions they arose, when we see them, and how they affect us. He rendered the results of his work visible in this color wheel. Here he has incorporated the general laws he discovered. For example, the complementary colors, the harmonic pairs of colors, are situated opposite one another. The harmonic pairs are an expression of the intercourse between the seeing man and the colored world. When the world shows us one color, we respond with its other half. Colors help to tell us about the world around us. They tell us that one thing is different from another. We would never spot the tiny berries if they weren't blue. The colors help us to differentiate. They tell us about the seasons and the cycles of life. They show us laws governing the reality we inhabit. Goethe concluded that colors affected us, body, mind, and soul. So his Weimar home was carefully composed. The yellow of the dining room walls creates warmth and pleasure. The green-blue hue of his study inspires calm and stimulates the mind. There are many different forms of color: chemical colors in flowers and trees, physiological colors like the colored shadows, and prismatic colors which arise when light is refracted by a prism. Crystals and raindrops can refract the light into all the colors of the rainbow. In order to study the refraction of light, Isaac Newton, the British scientist, constructed a triangular prism. And in 1704, he presented his theory of refraction and color. In his experiment, he shone a sunbeam through a prism, thus refracting its light. He called the colors that thus arose a spectrum. He concluded that the colors were components of white light. Goethe knew of Newton's theory. To test it, he borrowed some prisms from a friend. He looked at a white wall and thought he would see a spectrum. But all he saw was the white wall. But when he looked in the direction of the window, something happened. In the boundary between the glazing bars and the window panes, colors could be seen. Newton had concluded that the colors were contained by light alone. But to his amazement, Goethe now saw through the prism that colors only arose in the boundary between light and darkness. And he also saw more colors than those Newton had observed. But where there was nothing but white, there were no colors. Here are the colors Newton and Goethe saw. Here are the colors only Goethe saw. Newton didn't see these. It was as if he only included half of the colors. Goethe included both spectra in his color wheel. In his experiment, Newton tried to isolate sunlight in a darkened room, and then from geometrical descriptions, he deduced his theory. Abstract observation and isolated experiments are the foundation stone of the natural sciences, which our modern technological society is built upon. For the last 200 years, the watchword of classical science has been objectivity. Goethe's view was that sensory perception was important because it links us to the world and gives us knowledge of it. His investigations remained within the reality we can see and sense. He maintains the association between part and whole. To gain knowledge of the world, he says, we must first dismantle it, but then we must reassemble it to return it to its true context. When Goethe describes colors where he sees them, he obtains an insight into the world that is revealed through the colors. He emphasized that it was important to observe the phenomena of color without pleasure or displeasure, without expectations or prejudice. If we see them as they really are, they open up and tell other stories. According to Newton and the Western cultural heritage, colors are solely a matter of light. So we have never concerned ourselves with darkness. The natural sciences call darkness the absence of light. But you can't observe a ray of light or a ray of darkness. That is not a ray unless it is surrounded by darkness or light. In visual reality, light and darkness are equals. Therefore, Goethe says, we cannot talk about light without talking about darkness too. For example, if we look at these rays striking the mirror, we discover that light and darkness can both reflect. Science describes light as bundles of energy or electromagnetic waves. But deep down, we still don't know what light is. What we do know is that we can only see it when it strikes something. Although the rays of the sun are everywhere in the darkness of space, we only see them when they strike other planets. What we see here is Earth, not the light itself. Light is invisible and only becomes visible when it encounters matter such as the moon, the Earth, a hand, or some countryside. Smoke is also matter, particles that reflect light. The smoke is what allows us to see the light in this box, just as we only see the light across the lake because it strikes the mist. Now we've covered the hole in the box with glass so the smoke cannot enter. The beam of light is still crossing the box, but we can't see it. In itself, light is invisible. We are used to talking about sunlight, but the light we see is really luminescent matter, namely glowing particles. Liquid iron also gives off light, as does the incandescent filament of a light bulb. All sources of light are luminescing matter. When daylight disappears, the darkness of night takes over. In the darkness, we find peace and quiet. Darkness is one half of our lives. We see the darkness at night. We see darkness in the shadows. We see darkness when we gaze into empty space. You might say that darkness is space, space containing invisible light. We associate light with matter and darkness with space. When night falls, shrouding the countryside in darkness, and light no longer plays on the cliff, the trees, and the pebbles and rocks at the water's edge, the space of the universe takes over. The world becomes cold and distant. But when light from the first glow of dawn spills onto the cliff, and the treetops once more turn green and distinct, and the dark sky turns blue, the world becomes textural and present. In hot, abundant Tuscany, where the heat makes the soil steam and the light strikes the mist in the air, the grapes, sunflowers, and other plants, we are enfolded into a textural presence. In the cold Norwegian fellscapes, where the air is pure and clear, and plant growth sparse, space and remoteness dominate. We feel small in this vast outdoor space. We cannot perceive space without matter, or matter without space. In our perception of reality, matter and space are inseparable. The same goes for light and darkness. Light and darkness form a fundamentally opposing pair. Goethe called it the light-darkness polarity. The atmosphere and experience of the park's own spaces shifts according to the distribution of light and darkness. The contrast between light and darkness absorbed Goethe, both as a poet and observer of nature. In the celestial phenomena, Goethe studied the encounter between light and darkness and the birth of colors. Part of the Earth's atmosphere consists of dust and particles that Goethe called Trübe. In the Trübe sphere, light meets darkness and the colors are born. At sunrise and sunset, when the white light of the sun passes through the Trübe, we may observe the marvelous sight of the colors playing on sky and earth. To explain what happens, Goethe ordered pieces of glass to be mounted in the lid of the box. They are colorless, but translucent, and thus have the same effect as the ash and particles in the Trübe sphere. When the lid is closed and we look down through the glass into the darkness of the box, the glass looks blue. When we open the box and look through the glass into the light, the glass turns yellow. The snake on Goethe's glass has the same Trübe effect. When we see the snake with the light behind it, the snake looks yellow. But if we see the snake against the dark background, we see the snake as blue. It's the same phenomenon that gives color to the sun at sunrise and sunset. We see the white sun as yellow and red when we see it through the Trübe sphere. The denser the Trübe sphere, the redder we see the sun. The yellows arise in an interaction between our vision, the Trübe, and the sun. When we look at the sky, what we are actually gazing into is the darkness of outer space. But we see it as a blue sky when the light from the sun passes through the Trübe sphere that's just in front of it. The particles of the Trübe sphere reflect the light. There is thus light in front of the darkness. The thinner the Trübe sphere, the darker blue we see the sky. The blues arise in the interaction of our eyesight, the darkness of outer space, and the illuminated Trübe. The colors belong to our eyesight. When we look at the darkness through the illuminated Trübe, we see the blues. Blue is illuminated darkness. The blues are born out of the darkness with the help of light. When we look at the shining sun through the Trübe, we see it as yellow and red. Yellow and red are darkened light. The yellows are born out of the light with the help of darkness. We see the polarity of light and darkness transform into the color polarity of yellow and blue. Light forms the starting point for yellow and darkness for blue. Yellow and blue form the basis of all the other colors in the color wheel. So Goethe positioned them across from one another in his circle, yellow on the left, blue on the right. The two glass stairways are full of yellow and blue fluid. In the lowest steps, the color is yellow, but the more layers, that is, the denser the light yellow becomes, the redder it gets. The same applies to the blues. The cyan blue gets darker and darker, rising to violet the denser it gets. Goethe called this the color Steigerung, or intensification. Goethe shows in his theory of color that the concept of intensification recurs in phenomena as different as molten iron, a flower, a feather, the sky. Everywhere the same pattern, from yellow to red and from cyan blue to violet. In the horizon at sunset, we see the blues intensify towards the darkness of the sky and the yellows intensify towards the setting sun. The blue Steigerung goes from cyan blue to violet. We associate the yellows with the properties of light. We perceive them as warm and textural. We associate the blues with darkness. We perceive them as cold and spatial. The yellow flowers come towards us. The blue flowers recede into what is almost a blue abyss. We ascribe properties to the colors corresponding to the polarity of light and darkness, such as hot and cold, proximity and distance, major and minor. And we use colors to describe things in our lives. Golden eras, feeling blue. Although each one of us is unique, we perceive the same blue sky and golden sun, and fundamentally we react to them in the same way. We talk about looking on the bright side, or casting a shadow on proceedings, or having a sunny or a gloomy disposition. We recognize in ourselves the polarity of darkness and light from the world about us. The phenomena of the sky are where we see most clearly how colors arise out of the encounter between light and darkness. We see both the color intensification and polarity. That is why Goethe called it the primordial phenomenon. In Goethe's scientific method, then, the colors are described where we see them. So he insists that we ourselves are part of the experiments. We cannot separate the seen from the seer, he says. But just what is seeing? A white triangle against a black background is a very simple picture. If we remove the light in the form of the white triangle, we no longer see a picture at all, just darkness. A black triangle against a white background is another very simple picture. If we remove the black triangle, we don't see a picture anymore either, just light. A picture comes into being in the encounter of light and darkness. Here, the picture is the white wall and the dark shadows. As we can distinguish lightness from darkness, we experience that we are seeing what we call a picture. Here, the picture consists of the white petals, the violet androecium with its orange heads. The world comes to us in the shape of pictures, and through them we recognize the world. From infancy, we gaze out into the world and build up our ability to distinguish our experience and knowledge of that world. We find our bearings within it and recognize it through what we see. The knowledge and experience we have built up of the world by observing it comprises yet another picture, namely the picture of our memories or the picture of our consciousness. We always carry our knowledge and experience around with us. When we look at the world, an encounter takes place between what we see and what we know. The image of the world and the image in our consciousness are inseparable, like light and darkness. Goethe's investigations took place in the world of pictures because he described what he saw. That is why his prism experiments differ markedly from Newton's. Newton theorized about an isolated ray of light, but there is no such thing in visual reality. We can see as much by looking more closely at the first part of the classical experiment. The sunlight passes through a small hole and strikes the opposite wall. The result is what we call an optical image, a picture of the sun. It's a principle called camera obscura, dark chamber, and known in Europe since the Middle Ages. When the light from the sun passes through the hole, an image of the sun is formed. What we see is not an image of the whole. The sun contains its own image. No matter how small the hole, and no matter what shape it is, a round image of the entire sun will always be formed, surrounded by the darkness of space. It is not an isolated ray of light. The bulb in the camera obscura emits light into the room. Some of it escapes through the tiny hole in the wall and strikes the screen. Not only is the image of the bulbs depicted through the little hole, but the darkness around them too. That is why we see the picture of the arrow. The light always carries a picture of its own source. Here, the source is the entire radiant image of the tree, the yellow field, and the blue sky. Newton knew that the shining dot on the screen was a picture of the sun. But when he tried to investigate why colors arose when the sun's image was refracted by the prism, he left visible reality and the image of the colored suns. He did so in order to seek a proof of why colors arose based on the contemporary perception, that everything in the universe consisted of tiny, invisible building blocks or atoms. He was looking for the atoms of the colors. Newton imagined that light could be split up so that just one isolated ray passed through the prism. He defined his theory of colors using an objective yardstick, just as science today strives for objectivity and defines the colors in terms of different wavelengths. Science can explain colors without observing them. The natural sciences show no interest in darkness. It is merely the absence of light. But it is our ability to see and interpret pictures that links us to the world we live in. Pictures that arise in the encounter of light and darkness. Newton presented a theoretical interpretation of the prism experiment, but Goethe chose to examine what he actually saw. He began to explore the image of the color spectrum. He replaced a white square against a black background for the round sun. When the image was projected through the prism, he saw two color spectra, a yellow-red one above and a cyan-blue-violet one below. He observed that it was in the horizontal boundaries between light and darkness that colors were born. He called the two spectra boundary colors. The boundary colors may also be seen in the sky where day meets night. But the green from the Newton spectrum is not present. We send the white square against a black ground through a special prism. This prism can open and close. This enables us to observe the birth of the colors as a dynamic process as the image is refracted. When the prism is closed, the image passes straight through, just like a window. When the prism opens, the image is refracted and shifted upwards. We now observe the way the boundary colors arise as the prism opens. Yellow-red below, blue-violet above. The yellow and blue marginal spectrum arises, culminates, and disappears as the image is shifted. If we substitute a bar for the square, reducing the distance between light and dark, something else happens. As the image shifts, the two boundary colors arise as they did earlier, but because the gap between them is smaller, they meet, and yellow and blue mix. The color green appears. We observe that Newton's spectrum only arises as a particular phase of Goethe's two boundary colors, when they are close together. It is the distribution of light and darkness in the image that determines whether Newton's spectrum arises. Newton concentrated on a theoretical definition of the colors. Goethe explored them as dynamic processes. Everywhere, in prisms, in celestial phenomena, in nature, he observed and recognized the birth, culmination, death, and rebirth of the colors. He sought general laws. One of them was that colors arise where light and darkness meet. If we look at the black tree against the white background through the prism, we recognize the Newton spectrum with its bright blue, green, and red. But where the black branches are very thin, we also discern other colors, namely pale yellow, magenta, and cyan. The image that produces Newton's spectrum is a white bar against a black background. In the black bar on the right, the boundary colors switch over, so that red and violet meet and merge into magenta, the way yellow and blue merge to form green. Here is the dark spectrum that Newton found, together with the light spectrum that Goethe added. The light spectrum and the three light colors. The dark spectrum and the three dark colors. Goethe incorporated both the light and the dark spectra into his color wheel. In the color wheel, we recognize all the general laws the colors abide by everywhere in nature, the nature we are a part of. Because recognition is harmony, Goethe calls his color wheel the harmonic color wheel. Green forms the base of Goethe's color wheel. It arises as a blend of the two primary colors, yellow and blue. The polarity is suspended, and balance and calm emerge. The color green belongs to the earth. Everything, yellow and blue flowers alike, start from a green sprout, just like every other plant on earth. We may talk of the earth's green cradle. Magenta forms the top of the color wheel. It arises as the culmination of the encounter between red and violet. Here, too, the polarity is suspended, resulting in a sense of sublime peace. Clear light is everywhere, Goethe said. It hastens through space and only becomes visible when it is braked, when it meets resistance. Light and darkness are engaged in a never-ending struggle. Sometimes light wins, sometimes darkness. Even in a pansy, we recognize light and darkness. Colors are born out of light and darkness. They always have been and always will. We are part of the world of colors, and through them we gain knowledge of the world and of ourselves.